Hi, good morning everyone. Welcome back. So here today we are going to discuss about the topic called pole basis and shaft basis system. So where it is used. So in the previous classes we have seen about what are the different types of fits that are available and selection of the types of fits which are requiring and satisfying the purposes. So further, if you go through this particular topic, we can able to analyze the things better. So see, in this particular topic, here we can able to identify what are the different types of problems that are arised in whole and shaft basis system. We are going to see in this particular session. Hope you are able to enjoy this particular session. And so, what is important terms that are used in the limits? As you have already seen, what is the nominal size, what is the basic size, what is the actual size, where you can able to segregate the differences between these three based upon what the matter that is conveyed to you. So the size of the basic size, you can able to observe that the size of the part of which all the limits of variations are applied to arrive the final dimension of the mating parts. The mating parts are nothing but the shaft or the whole assembly. Okay, see, if you go into this particular thing, the following are the two bases of the limit systems where pole basis system and shaft basis system. So these are the two figures representing one is the whole basis and second one is the shaft basis system. So here if you can able to observe, see in the first condition, see when the whole is kept constant number, that is the lower deviation of the whole is 0. We are making it as a 0 value, and different types of fits are being obtained by varying the size of the shaft as shown in the figure. So the limit of the system is shift. This type of system, if you can able to analyze, it is a whole basis system where the first whole is kept as the constant number, whether it may be a 0. The second condition, shaft basis system, it is quite similar and opposite to the whole basis system where the shaft is kept as a constant number where the upper deviation of the shaft is 0, and the different fits are being obtained by varying the size of the hole. Okay, then this type of limit is said to be a shaft basis system. See here the shaft is kept in the previous condition, hole we are keeping as a 0 value. See, not exactly 0, a constant number, whatever it may be. Next, in this condition, the shaft is kept as a constant number and we are varying the different fits by varying the size of the hole. The previous condition, we have varied the size of the shaft. Okay, this type of condition, the limits are said to be shaft basis system. See here, hole basis system, we are varying the size of the shaft. Here we are varying the size of the hole. I hope it is clear. Okay, so see here we are going to see one problem which is related to it. A mild steel rod which is having 12 diameter and it is tested for tensile strength. The people know what is tensile strength, and with the measuring gauge of 60 the following observations are being recorded, that are the final length of the particular specimen is 80 and final diameter of that particular specimen is 7 and the yield load is at 3.4 kilonewtons and ultimate load is 6.1 kilonewtons. So from this data, we should calculate what is the yield stress, what is the ultimate tensile stress, what is the percentage of reduction in area, and what is the percentage of elongation. So this is the problem that they have given. So from this, see, I think we have already discussed what is how to calculate the yield stress, ultimate tensile, and we have to see the percentage of reduction and the percentage of elongation. So see how we are going to calculate. So we have to write the given data. So these are the dimensions, and see from here we are going to calculate area is equal to initial diameter capital D square 12 pi by 4 into 12 square, you're getting the area. After after elongation, what is the final area? We are calculating A into pi, that is nothing but pi by 4 into small d square. This also they have given, and from that we are getting the areas before and after, and then from that we are going to calculate the yield stress. Yield stress they have given and the area we have taken it, and from that we are going to calculate the yield stress is nothing but 30.1 megapascals. And next, ultimate tensile stress. For this we are having a formula W by A, where you are getting calculating and getting the value of 54 megapascals, and from here we are going to calculate the percentage of reduction in area. It's nothing but initial area minus after elongation how much, and by original area we are getting the value in terms of 0.6666 percentage, and percentage reduction in area is nothing but the diameter, and also we are calculating the elongation value. So see here we are calculating capital N minus small l by 80. So here we are getting the initial length minus reduced or increased length. We are able to get this value. Okay. Next, working stress. When designing the machine parts, it is desirable to keep the stress lower than the maximum or ultimate tensile stress at which failure of the material is going to take place. Next, this type of stress is known as working stress. Okay. It is also suitable to say that it is safe and also allowable stresses, we can say. See, here you have to make a note that if that particular failure is not meant by actual breaking of the material. Sometimes machine parts may set to fail when they have amount of plastic deformation which is set in them. Okay, so this condition you have to read it. Next, another problem we are going to see. A mild steel rod of 12 diameter was tested for tensile strength and having a gauge length of 60 And what are the following observations are being made? Final length is 80 final diameter is 7 of the specimen, and yield load we are getting 3.4 kilonewton, and ultimate load we are getting 6.1 kilonewtons. So they have asked us to calculate what is the yield stress and what is the ultimate tensile stress, what is the percentage reduction in area, and what is the percentage of elongation. Okay, so this problem we have seen. So I think similar problems we can able to practice, and it is a very simple topic. So I think hope you have understood. So we are moving to the next topic. Thank you. Have a nice day.